All right, number 3, we want to find Q divided by R of X. So this time we're not plugging in a specific value. So this time we're just going to get the Q function, which at the top we're given Q is the square root of 8 minus X. And the R on the bottom is just 5 times X. And we want to find the domain for part 2. So let's go ahead and get part 1. We're just going to put those functions in. And then part 2, we're going to find the domain. So since this is a rational expression, we got to remember we cannot divide by 0. So the only value of x that would make the denominator 0 is 0. 5 times 0 would be 0. So x cannot be 0, so we're going to remove that number from our domain. And then we have to find out what values of x would make the expression negative, because we can only take the square root of positive numbers. So when you have a square root, you figure out domain by taking the expression under the square root and setting it greater than or equal to 0. If we subtract 8, we will get negative x greater than or equal to negative 8. Divide by negative 1. When you divide, the signs change, and so we get a positive x. The inequality sign flips, and this becomes a positive 8. So if I look at a number line, we go from negative infinity to positive infinity. The number 0 we would have to remove. Okay, so this number is going to get removed. That's going to split my number line into 2 sections. This interval is saying that you can use any number that is 8 or less. So we will start at 8, and it will be in a bracket because we can use 8. And we will go all the numbers left of 8 except for 0. And then we will use all the numbers from here to infinity. So our domain is kind of broken into 2 pieces. It is from negative infinity up to 0. Okay, not using 0, so we'll put parentheses to indicate that. And union, we would also use the other side of 0 up to positive 8, and that would be in a bracket. So double parentheses, negative infinity to 0, and we'll do a half parenthesis and then a bracket. So that's going to be on the other side of 0 up to 8. And that's good. Number 4. It says refer to functions s and t, given here. We're going to find the indicated function and write the domain in interval notation. So we're going to do s times t, okay, which they're showing us here. We're just multiplying those 2 together, and then we'll write the end result. Now what they're doing here is they're showing you the factor form, so they're going to factor it first. So we have x minus 1, and then x minus 16. Okay, so that is a difference of squares. If you remember, difference of squares is a squared minus b squared, two terms that are perfect squares, a factor to be a plus b, a minus b, difference of squares formula. So I'm going to do that to the x squared and 16. 16 as a perfect square is 4 squared. So if you just imagine this like this, just remove the squares, and so we'll have an x plus 4 and an x minus 4. So that's what we're doing first. That is being multiplied by x minus 4 divided by 1 minus x. Okay. the x minus 4, since it's being multiplied and it's on the top and the bottom, we can divide that out. This term, we can do a little bit of algebra. If I rewrite it, it looks like a negative x plus 1. Looks close to this, except for the signs are opposite. So if you factor out a negative 1, both the signs will change, so that will become a positive x, and that will become a minus 1. So now we can cancel this term. Okay. So at the end of the day, this is just going to divide out to be a 1 over x plus 4. And then on the other side, we're multiplying by 1 divided by negative 1, because all of this divided out. Okay, so going straight across, we get a 1 over, and we just put the negative out front, x plus 4. I'm going to say negative 1 over x plus 4. So first the factor part, x plus 4 and x minus 4. Now it wants us to simplify. Negative 1 over x plus 4. All right, and so the domain of S, okay, so the function S, what makes the bottom 0 from the original problem, we cannot use positive or negative 4. So when you think about your domain, again, I always make a number line, so I can put it in interval notation. It helps me to see that. Negative 4 is going to get removed, and also positive 4. So that splits your number line into 3 sections. Okay, negative infinity to negative 4, the other side of negative 4 to positive 4, the other side of positive 4 to positive infinity. So these are how my domain is going to be. Look for S, and then for T, we cannot use x equals positive 1. So positive 1, remove that point, and split your number line into 2 sections, negative infinity to positive 1, and then the other side of positive 1 to infinity. So we'll put these 2 for our domains. This one looks good. And then for T, this one is good. And then it says we must also exclude values of x that make the denominator 0 in S times T. So in this case, we're going to exclude negative 4. And it says, however, the value of x equals negative 4 is already excluded. So the intersection of these domains of S and T is represented by what? So when we overlap these two together, it just ends up being this one when we do the intersection. So negative infinity to 4. Well, I guess we would need to also include that 1. So we're going to have to put them together. So if you put them together and like merge them and remove all the points, we would also be removing the 1. So adding the number 1 here and removing it, we just add from negative 4 to 1 and then 1 to 4. So it adds another separation in between here. And so that's what we're looking for, the combination of both. Negative 4 to 1 and 1 to positive 4.